Hi y'all. So I'm recording this video for Vanderbilt University AI course, project part two. Before we start, on my left side, that's the code I wrote. As we say, it's all written in Java. And on our right-hand side, it's a PowerPoint. Um, it helps us to it helps me to better present you about this whole code and structure as well as the algorithms and some improvements I did on part two. Right, so let's get started. Give a little bit of background. Though this is a project to build a multi-method AI that plans and models trading and development decisions for respective virtual countries. Now, for part one, it is all the virtual countries is being generated by the code itself. Well, of course, it is code now, but before it was generated by a code and it's stored in a constant class. Where on our second part, we generate the countries and all the corresponding resources. We stored it in the DynamoDB and read it from zero. So yeah, so like this scenario will be more close to um, the real world case where our data is pulling from database instead of some constant class. Right. And as I just said, all the resources is also generated by the code and stored in the database, and we read it from there. The constant class is still kept right now, but I guess in my next push, which is in next half hours, I'll just remove this constant class and all the other unnecessary part. Here's a link to the code. The link to part one video, and I will add so YouTube link to part two as well later. Yeah, cool. Let's go to the old design. So I have covered the old design in my previous video. So in this one, I'll just talk about the improvements I did. One minor change I did is on the operation part, where it allows us to print out the steps a country or the action countries make. I also added a function, a method in state variable, state class. Well, it will better help us if it like print out all steps or history steps efficiently without a bunch of for loops or while loops. Now, the big improvement I did is on the success generator strategy. Well, still I'm using the proving strategy, but I did a lot of improvement there. Because I run the code in my local machine, so before it can only handle two countries, and it can go as deep as level 4, which is not a lot. But now it handles three countries, and can go deeper to, I'll say, level 10 on my local machine. Also, just want to let you know, my machine is 16 gigabits RAM with a 16 gigabits RAM, so it's not that fancy. But there's a big improvement to me because handle one more country means a lot of tons of more nodes on the graph. And also before we generate the graph as a whole, before actually go through the nodes, go through the paths. But now we only generate the node when it's needed, or when we need the child path from the certain node. This is some improvement I did for the search strategy. Just it better helps us to clean the cache when you see there's unnecessary paths. So if you find a node that is way too less, which makes it meaningless to be there, we just simply remove it from the queue. For example, say if we transfer 4 population to the other country, Now there's a better option of transfer 8 population to the other country. We just simply get rid of transfer 4, the option transfer 4, because as mainly it's too easy. Anyway, let's go ahead and go to next section. So yeah, search algorithm design. So as I said, it now only generates the child paths when it's needed or when it's necessary to have them in the cache. And the reason why data is it increases performance, removes unnecessary data on our computer stack, where we can handle more countries as well as a deeper depths. Going to next, it's discounted reward algorithm design. I didn't do much on this part. Everything the same as part 1. Everything's provided from class. Now, one improvement I wish I could add is combine multiple transfer actions, but I haven't decided how to do it yet. Probably we'll do it later. Basically, what happened is when you ask the other country to transfer to you, you always have to give something back, or you will need to allow the other country to transfer you some wasted resources, or I'll say like polluted, other pollutions, along with the use for the resources. Yeah, just make it so it makes more sense. But for next part, the pre-insert improvement, I did a lot of code change there. Well, I generated the successor in 2 ways. One is the transfer operation successor. The other one is a transform operation. Right? Let's first go over the transfer operation successors. So this is what I did before. So basically read the maximum resource the other country has, and we go from there. So say if it has 6 water, you cannot go over 6, right? It's some basic knowledge. But the one improvement I did here is I added a for loop to calculate the basic factor of each resources. Let's say this: if we want to create a metallic alloy, and that requires, for example, 3 water, 1 population, and 1 housing. And this is just an example. Now, if we want to make another created resources, it requires 2 water. Then the water resource used to transfer has to be a multiple of either 3 or 2. Because it would be meaningless to just get 1 water, because it won't give you any ability to actually create anything. So yeah, that is meaningless. I figured that is meaningless. So I added this code here to figure out the factor, the basic factor where we can get multiple from there. I'd get rid of a lot of nodes in the child paths, but I don't know if I did it right. Idea come to my mind. Now come to the transform operation successor. It now provides the recipe factor, where it makes sense because say if you want to make a 2 metallic alloy, so you have to get it has to start from constant 1, 2, 3, 4 times the resources you're going to use. This is also an improvement I did here. Before everything is kind of hard coded. Right. So these are some improvement I mentioned before. Take average score. Yes, I also added a method there to take the average score more efficiently. Yeah, this is prepared for multi-transfer reactions. Um, as I as we discussed, when you ask the resource from some country, you also have to take some polluted resources or give something back, just to increase the possibility of the other country of accepting the trade. Um, Now, since we put a list of operations under one state, of course, we have to take the average score. Um, so it has a more meaningful weight. Cool. So as the first part, I'll do a quick sample output here. So it's 3 countries, and we want to print it. I'll just start the program. I believe the performance is hugely increased from the previous one. Previously, it takes a couple seconds. No, not a couple seconds. I'll say 20 seconds to print out other results. But now, 3 countries, 5 depth level 5. That's only 6 seconds. No, 0.6 second. I'm sorry. Yeah, this is way faster than the previous code. Oh, yeah, just to show everything is not hard coded, and as the result will change. A couple more tests here. Run again. Well, because every time the resources is randomly generated, so the result, of course, will be different all the time. Run it again. Now 5 seconds. Run again. 0.7 second. Run again. Yeah, now this part is just to prove that everything is not hard coded. The data is randomly generated. The result is kept changing. So cool. Thank you.